Hello?
Hello, can you hear me?
Yes, I can hear you now. Can you hear me?
Yeah, I can. Thanks. How are you?
Good. How are you?
Yeah, great. Thanks.
Yeah, so I guess to start with, do you want to
Yeah,
tell me a little bit about yourself, your experience, and how long you've been doing the interview prep?
yeah. I have around like 10 plus years of software development experience, mostly on the server side programming. And I have been preparing from like last 6 months, and I have an on-site scheduled from the Facebook on yeah, in next week.
Oh, awesome. Yeah, I have my first phone screen with them in 2 weeks, one and a half
Okay,
weeks.
cool.
Yeah, so I guess to start with, I'll give you a problem, and if if you've seen the problem before, then I can give you a different one.
Sure.
But this question will be good because I think Facebook tends to ask a similar question.
Okay.
So I'll put it here in the comment down here.
Yeah. All right.
So you're given the root of a binary tree and you're standing on the right side of the tree.
Yeah.
Return all of the nodes that you can see, ordered from top to bottom. Have you seen this question before?
Uh, Not exactly, I guess. Yeah, so we have a root of binary tree. Imagine yourself standing on the right side of it, return the values of the nodes you can see ordered from top to bottom. Okay, so I'm imagining that this tree has at least one node, right? Like as root.
Yes.
Um, and the right side view means like so this binary tree has different levels, and for each level, basically, we are saying that we have to pick the rightmost node, right? Uh, so that will be like the right side view. So, for example, if we say like tree as something 1, 2, 3, 4, 5, 6. So basically, right side view will be 1, 3, 6, right? And we have
Yeah.
to return from the order from top to bottom. Okay. So yeah, one thing that comes to mind that we can do like that first search iteration and like level by level we iterate over it, the tree, and pick the last element of the um, that level and add it into the result array that we have to return. Um, does that sound okay? So there there may be like depth first search solution as well, but since breadth first search and depth first search in this both case will be like linear complexity, time complexity. Um, so and from the time space point of view also, since we will be maintaining a queue here, uh, and in the depth first search space will complexity will be again in the worst case linear. Um, so we can pick either of the solution like breadth first search or depth first search. So basically, I will be using the BFS, the first search, and do level by level traversal. This
Okay.
is just the approach that I'm trying to mention here, and pick the last, pick the not the last, but pick the right most element of that level. Does that sound okay?
Yeah,
Uh,
I think that's fine.
All right. And we don't have we can use like tree node kind of a structure here, something like if I use uh, syntax of the C++. So node will be having like a value, and there will be like two pointers pointing to the left and right circle. Okay, and yeah. We are not going to create the tree. I think we'll get a pointer to the root as the input of the function, right?
Yes.
So we can say here that so we have to return the values of the nodes. So we are going to return an array basically. So I can say send function name right side view here, and as input we are getting this root node. So in the worst case, in the edge case scenario, if we see that if root is null, then we can just return the empty array. Otherwise, what we will do is that we are going to maintain a queue here. And the queue will start with the root node first. And this will be the result array that we are going to create while we are traversing the tree. And during the iteration, we'll say that queue should not be empty. Once the queue is empty, that means we have completed the whole traversal of the tree here. Then basically here from the queue, we'll just take out the first element. Right, since we have to do the like level by level traversal, I can do like take the size of the queue first here, and then iterate basically over the array. And before doing that, I will. So what I will do is that I will when I am iterating over the queue at each level, basically whatever is the size of the queue, I will pick the last element of the queue and insert into the array before we iterate over the list. So that way we are making sure that we have the exact element that we need here. So we can say in this case, like to take the last element of the queue here, which will be going to be a node, and take the value of it, something like that. And then iterate over it. So initially we had the root only, so we inserted the root's value here, and then iterate over it. Like this. And right, so we'll then take the from the queue, we'll take the first element, which will be like the leftmost element at this time, at this level, at the start of the level traversal. And here we'll say that if we find the left node, then push it into the queue here. And similarly, if we have the right element, then we just push the right element here. Okay, so if we see and result, we are going to push only when we are starting the level traversal, since we are sure that we are going to get the last element here, and then we are going to say return result. So just for the testing purpose, if we say check here, like in this 1, 2, 3, 4, 5, 6 case, so when we starting, then queue has the element 1 at the start, and result we are pushing as 1 here. So size of the queue is 1 at that time. We take out the first node, and we say that we have like 2 and 3 as the left and right child here. So queue has the element 2 and 3. 2 is at the front, 3 is at the back. And second time when we come into the while loop, we see the size of the queue as 2. And in the result, basically, we put the number 3, which is the back of the queue, the last element. And so when we are iterating over the node 2, which has, like, for example, 4 and 5 as the left and right child, and 3 has only, suppose, for example, only left node, not the right node. So 6 is the left node of the 3. So what happens here, that queue becomes first like 4 and 5, which came from the node 2 here. And when we are iterating over 3, then there is no left node, but there is, there is no right node, but there is a left node as value as 6. So Q will become 6 here, 4, 5, 6. So when we come for the third level of the traversal, in the result, basically, we are pushing the value 6 here. And this way, we have the result as 1, 3, 6. So in the edge case, suppose, for example, only 2 has only one node as 4. So right side view still is like, should be picking it 4. And we'll make, so that will happen like when we are at node 2 and size as 1, we will be inserting one of the node here. So Q in the end will be only 4, and the result will change to 4 here. So in that way, we are making sure that if there is any element existing, at least one, then also we are inserting it into the result.
Okay.
Yeah. Does that sound okay?
Yeah, I think that makes sense.
Yeah. Okay. And yeah, time complexity is linear since we are iterating over each node only once, and space complexity is maximum in this case will be the level number of nodes at any level. And if this is like a full binary tree completely, so like height h tree has like 2 raised to power h nodes in the last level.
Sure. Yeah, that sounds right.
Yep.
Yeah, if you want to go ahead, you can come up with like a test case and test it.
Right. So this was the one test case that I was looking, like 1, 2, 3, 4, 5, 6, and other tests can be like, are you saying that to run the code or?
Yeah. Do you want to try and run it to see if it works? Because I'm not.
Okay.
I normally do Python, so.
Okay. Right. Yeah, we can try it out. Right, I will have to create the tree actually for it. So for one node only, suppose we have the root as 1 there. So at the end of the
If you want, I can give you the full definition of the tree node from LeetCode.
yeah, so it's working. So like for one node, we got the value 1 here. Then it's like, since I have to generate the test case manually, so I will have to create the nodes, and set the left and right pointers. So it's like,
yeah.
So here, so this is the case in which like our root node 1 has the child 2 and 3, for example. So I will just create a left node with 2 and right node with value 3, and I will just set here as root left as left and root right. So now a root node has 2 child here. I will write the destructor here. So yeah, 1 and 3 is printed. So like that is the right side user. Yeah. So similar, I think it should work, I guess.
Yeah, I think that makes sense, and the solution seems to be working. We still have plenty of time. If you want, I can give you another problem.
Yes, please. Yeah, sure.
So same thing here. Let me know if you've seen it. So in the bottom, I can post it here.
Mm-hmm.
So you're given an integer array of numbers and an integer k. You have to return if it's possible to divide the array into k non-empty subsets whose sums are all equivalent.
Okay. So for okay. So each subset will have the same sum, basically. K non-empty subsets whose sum are all equal. Okay.
Yeah.
And subset
like
means
that.
here like the contiguous subarray, right?
Yes.
Not the subsequence. Okay. So for example, in this case, k equal to 4 and this, so that means so we can divide somehow here, like 4, 3, 7, 9. 2,
So you would have to create 4 subsets from nums whose sums are all equal.
Yeah.
To
in
each
this
other.
example, I can't see like which subarrays, but perhaps it is true, I guess. There will
yeah, so you will have these subarrays here.
Yeah, right.
Oh,
So 4 subarrays we have to find in which.
you will have
All
5,
right.
1, 4, 2, 3, and 2, 3.
All right. Oh, so it's non-empty subsets basically. Like so this is a set, and all like if we get the power set of this set, then we have to pick the subsets, and we are able to have like 2 times because there is like 3 existing 2 times here.
Yes, and also 2 existing 2 times. So you can
Right. And 2
utilize
also.
each number once.
Okay. Okay. So 1, 4 is like unique. Okay. Okay. So it's not a contiguous subarray, but it's like a subset actually. That's why
Yeah,
1 and
yeah,
4 we can pick, like, because even though they are not contiguous.
yeah.
Right. I understand that. Okay. So it's like all 2 raised to power n subsets that can exist for this set. We have to figure out which subsets have the same sum. Okay. Um, so brute force method, I think here will be generating all the subsets first, and then iterate over all the subsets and check the sum. So, but it's like generating all the power set and generating all the subsets is like a um, quite like it's a huge like a space from a space point of view. Even it's like a huge going to be a huge array if n is large.
Yeah.
So I don't think that would be good scheme to generating like, and that will be like a lot waste of resources just to generate first. So somehow we have to figure out like um, so what I'm thinking is that since we have to have k equal subset sum, so first take the sum of the whole array, like one, like the accumulated sum, and then divide by k, so that we will know like what is our target sum that we are looking for, right? Uh, and uh, and if we are not able to divide it by k, then we can return immediately false, since it's not possible, right? And I hope that k is not 0, right? And it's a valid number, right? K should not be greater than number of size of the nums array, right?
Um,
Or if it is like we'll just return false anyways. Like if I'm not able to divide the sum of this number, a number
K,
array by k with remainder 0, that means like I can't divide this into k equal sums, right? So that will be like first check, that first initial check basically.
yeah, you can assume that K will be less than or equal to the length of nums.
Okay. So what I'm thinking, like, get the sum of the nums array, divide by k, and check the remainder. Check the remainder. If remainder is not 0, so return false at that time. So this is like initial check, since we can't divide it in k equal subsets. And then then Yeah, sort of like start from the initial index, suppose element 4 here, and then pick try to pick k minus 1 elements. So since every subset has to have k elements, so if we pick first one, then we have to pick like k minus 1 remaining elements in that subset. Right. And if we are able to form like one of the subset having k elements, those elements will not appear into the any other subset, right? Since we are going to divide it into k. So from there we can think of we have some sort of marking that we can make on each element, whether we have already used it or not, kind of. So that will kind of prune our search for the elements. So we are not going to check for those elements which we have already formed with the sum total divided by k. So somehow I'm thinking about having a check array of size nums array.
Okay.
So in that I will mark. So in that mark that element as used. That element as used if we are able to find the subset with sum. So there is a total sum. Get the sum of nums array, which is like a total sum, and target sum is for each subset is total sum divided by k, right? This is the target sum. So and sum target sum. So once we are able to find one of the subset which has the sum as target sum, all the elements used in the subset will mark as the used element. So we're not going to visit them perhaps. So then this problem is like kind of a depth first search, kind of like I start with the one element as like a start index 4, for example. So start with the index 0 and look for what elements can be used to have sum as target sum, right? And the next time when we are iterating over it, when we are iterating over it, like suppose for example for the 4 we found the 1 as the sum as 5. So when I am, for example, at the 1 to iterate, I am not going to iterate over it since I marked it as the used element. But I will start with the 3. I will consider like other elements. So good case will be 3, 2 here. So those indexes I will not use. And then when I'm at 3, so when I'm at 3 basically, and I'm trying to explore, I will not use 5, but I will consider 2 as a element. And since 3 and 2 will make us 5, I will say that is the sum. And 4 is like mated with number 1 here to make the sum. So when we reach here, like that at the end, we have then consumed all of the elements. So this is what I'm thinking, like it's a kind of recursive function which will keep on looking into the elements and try to form the subsum basically. Does that sound okay?
Yeah, that makes sense. I think that's a good starting point.
Yeah. There may be some roadblocks here which I haven't considered, but this seems to be like a starting layout that I can work with. Okay, so and we have to return bool here, and we can give it name subset equal k kind of, and input is an array here, and k sum, right? Okay. So first thing is that we get a total sum that I was talking about here. So we can use a STL function, library function accumulate, which will give me, which takes basically the start and the end iterator for the array, and starting sum. Starting sum is 0 here. That will be like a total sum for us. Now here I'm going to check if so here I will just make an edge case here if k equal to 0, because that is a disaster case. I don't want to divide by 0 in any way here, so I will just say false. And this is our target sum kind of for each subset. So that will be divided by k. All right. And here I will say that if total sum percentage k. So remainder, if it is not 0, if it is not 0, right? Remainder is not 0. That means we are going to return false, since there is no way that we can divide it into k equals some subsets. Okay. So these are like initial checks here. Then we can have a mark array kind of that I was talking about, like which elements have been visited or not. And this is like the size of this input array. And here again we can say if size is 0, then return false perhaps. There is nothing to check, I guess. Okay, and the size is false. Initially, the whole marks array is false for all of the elements. And then I have to use the recursive function basically. So I will just say something like, let me figure out the signature of the recursive function, what it might be. So I'm going to, from the recursive function after iteration, I'm going to return as a Boolean element here. So first element is certainly the integer, the nums array itself, right? Then the second element is this marks array, which will keep on changing over the iteration of the recursion. Then there will be like some sort of start index, we can say, which is like from where we are starting for each recursive point. And then there will be like k here. K is the sum that we are. K is the this target sum doesn't make any sense actually, since k is the target sum. Sorry, this is not the target sum actually. Yeah, this is wrong. This is like how many of the subsets are going to be there, right? So num subsets kind of. Yeah. And yeah, we'll have to find the current sum. So at the iteration, when we are doing recursive call, we'll have to keep forming this current sum. And something like how many of them we have used, I guess. Yeah, how many of the current sum and how many numbers we have used here, basically something like current num and the target sum divided by k, total sum divided by k. Right. Oh, so yeah, this is right. Sorry, k is the like k equal subsets read. So this is the target sum. Sorry, I got confused here. This is the target sum actually that we have to look for.
Yeah, that's true.
Right, I got confused. So this is the target sum. So k is the number of subsets, and divided by total sum is like total sum divided by k will be the target. So this is like the target. So here, so we have a numbers array, marks array, starting index that will start from k is the number of subsets. Current sum is like for each subset, I will track what is the current value of the sum and how many number of elements I have used current num, and the target sum that I should look for. So this C is like a starting signature. I will keep changing here. Some of them might not be used here. So this is a kind of recursive call. So if we say that here the base case will be like if current sum we reach to the target, that means we have got a subset. And we'll say that if current number of the elements should be greater than 0 as well. So here we'll just say that that we found one of the subset at this time. Then we have found one of the subset. We can't return true from here only because we have to find other subsets also at this time.
What does current num represent?
Current num represents like how many numbers are involved into this particular subset, like one of the subsets only. So like for example 1,4, in this case current num first will be 1 and then at the end it will be 2.
Okay.
And I'm tracking here just to make sure that at the end this current num this current num should always be like greater than 0 whenever we are forming a subset. I'm not considering like an empty subset or something, just to make sure. I don't know what to return from here. Basically, I'm just thinking like I will just what to do here. But yeah, like from iterative point of view, like I will start from this index here, and I will say that I need to go till the end of this array. here then I will check whether whatever index I am going to start from or to consider for the subset, that should not have been already marked in the marks array. So I will say marks if only it is marked as false. Then we can say marks as starting as true. Right. And then right, marks as true, and at the end we have to marks as false as well, since it's kind of backtracking that we'll have to find all of the combinations here. So here we'll have to see the value of f helper nums marks, and the start index will be like I plus 1, whatever is there, I plus 1. And sum remains k here always. And current sum is changed to plus nums I. So this is the new contribution from the number, and current num also will increase by 1. Target remains the same. So, and here we check if this return value, if this is a true return value. I don't know when we are going to return true, but I'm not sure. If this is returned, then return true should be there. Okay, so here we'll have to find, like, if we found one of the subset as the value, then perhaps call this function again. The sum as marks, and start index again as 0 to start the whole process again. And k will have to reduce by 1 because we found one of the subset. So we'll have to look for k minus 1 subset now at this time. Current sum will again go to 0. Current num will also go back to 0, and look for the target here. Yeah. And yeah, right. I understand that now. So if we keep on reducing k, and we get the case when get the value as 1, that means we have found all of the subsets at this time. Like we started with, suppose for example 4, and we reduced to 3 first, 2 first, and then come back to 1. That means like we have all of the subsets formed at that particular time. So here we can say k is 1, then return true from that point. Right. So if we are not able to return true from in between, then we have to return false in the end. Yeah, so here then we'll have to say just return marks, start index is 0, k, current sum is 0, current num is 0, and target sum. Right. Okay, so let me think here if I have missed something. So if k is 1, then we'll return true. If current sum is target, then and current num is greater than 0, then I'm going to explore more for other subsets. and otherwise we'll start from start index, next start index, okay, and look for in the marks array that is true for that element. Yeah, and backtracking is needed here because when we are exploring and setting as the marks as true, but if we are not able to find the proper subset, then we have to reset it as false at that time.
Yeah.
To start exploring again. So for example, if I take one example here, smaller one, actually that's, so suppose this is the array, and k is 4. Okay, 4. We can take this example itself. So we start with 4 here. Start with 4 here. So current sum and the target sum here is 7, 9, 5. 5 is the sum, target sum that we are looking for. So when we start with value 4, then marks array is false for it. So I will have an array here, which is like a f false, false, false. Initially marked as all false here. 5 is the target sum. So when we start with 4 and initial index I is 0 and the current sum is 0. Okay. Then when we are doing the loop, we see that index 0 is false. We set that as true here. So we mark this as true here. And then again call the recursive function with again new index 1 and current sum as 4. Okay. Right. Current sum is 4. Current num is 1. And initial start index is 1 here. Oh, sorry. So initial start index is 1. At that time, we start then iterating from the second element, 3. We again mark that as true here. So we have 2 trues here, 2 true values here. Then we start from 3 here, and the current sum plus num size is 3. So total sum, we make it as current sum is 7. Yeah, there may be some kind of pruning here that I got current sum more than the target sum. Oh yeah, there may be negative values as well in this, right?
Let me check. I think all of the values can only be positive.
Okay.
Yeah, 0 or positive values.
Okay. So because when we get this current sum more than the target sum, then perhaps we can short circuit the iteration at that time rather than going till the end. Right, this time I am going till the end completely. So for that I can change it later, I guess, if I get time. So this time it will keep on going, and then there will be no reaching to the like current sum will never be as equal to target, and this will never be returned as true in the end, and we'll mark that all of them to false back again. I guess so. If I'm thinking it correctly. Right. For 4, names and marks here and start.
Yeah, so I mean, I think this looks good for now, and I can give you the reference to the problem, and you can try it out yourself if you like. But in terms of the solution, I think you have it.
Yeah, there may be some like over calculation that I'm doing, perhaps.
Yeah, there's definitely room for optimization because you're already exploring some branches with a existing combination of subset, which you might have found earlier if they're able to create a subset of target sum.
Right.
So so yeah, you can through like either through memoization or some other strategies you might be able to optimize that. But you can check out the solution here. I put on 93 the reference. There's also a solution to this problem that is based around bit masking.
Okay.
Using bitmask to generate the 2 to the n subsets.
Okay. Right.
But it's quite complicated. I think it's useful, and it's like a fancy way of doing it. Personally, like I had to really put a lot of effort in understanding how it works. So I'm not sure how useful it is, but just for your reference, if you feel like it. In terms of feedback, to just quickly give you, I think pretty much everything you're doing is fine. And especially I think for Facebook, they want you to code quickly because I think they may ask more than one question in the interview. So yeah, I think this is fine. Like you can explain your approach and then get into coding. Yeah, good job.
Okay, thank you. Thanks a lot.
All right, thanks.
Have a
good one. Bye.
Bye-bye. Bye.